In this endocrinology video, we will talk about the hypothalamic pituitary axis of the adrenal corticotropic hormones. So the hormones of the adrenal cortex, actually. The brain consists of structures that are very important in regulating the hormones in our body. The hypothalamus is actually the main regulator. The pituitary gland, which sits below the hypothalamus, is made up of the anterior and posterior lobes, and these are also important endocrine glands. But here we will mainly focus on the anterior pituitary gland. We're only going to talk about the anterior pituitary because we are talking about the adrenal gland and its hormones. So the adrenal glands sit above our kidneys, and we have two kidneys, and so we have two adrenal glands. Here is a cross-section of an adrenal gland. It is made up of an adrenal medulla in the center and the adrenal cortex on the outside or periphery. The adrenal cortex and adrenal medulla produces very different hormones, but in a way they are similar. Unlike the adrenal cortex, the adrenal medulla is stimulated by nerves. The brain sends signals down the spinal cord, and the nerves which are leaving the spinal cord are sympathetic nerves that will target the adrenal medulla to secrete adrenaline and noradrenaline, or epinephrine and norepinephrine. An increase in noradrenaline or adrenaline in our blood essentially will trigger the fight or flight response, and so it will increase the sympathetic activity. And this is what we will see when there is an acute stress, when we are nervous, when we are running away in fear, or get a sudden jolt of horror. But what about the adrenal cortex? Well, the adrenal cortex is responsible for long-term stress response, you can say. The adrenal cortex has actually three main layers, which can be remembered from the top as GFR, such as the GFR of the kidneys. So the very outer layer is the zona glomerulosa. F is for zona fasciculata, and R is for zona reticularis. Again, the adrenal medulla produces hormones for acute stress. However, in the long-term stress response, the adrenal cortex has a bigger role. Long-term stresses will actually just essentially cause the hypothalamus in the brain to release corticotropin-releasing hormone, which then will target cells in the anterior pituitary gland to release another hormone called adrenocorticotropic hormone, or ACTH for short. ACTH will enter circulation of the blood and target cells within the adrenal gland, specifically the adrenal cortex. It will stimulate the cells within the glomerulosa, zona glomerulosa, to release mineral corticoids, mainly aldosterone. ACTH will stimulate cells in the zona fasciculata to release glucocorticoids, mainly cortisol. ACTH will stimulate cells in the zona reticularis to release androgens. Out of these three hormones, the glucocorticoids has the very important role in providing a negative feedback to the brain. What I mean by negative feedback is that if there is an increase in glucocorticoids in circulation, this will send a negative feedback signal to the hypothalamus, telling it to reduce the production of corticotropic releasing hormone, and thus reducing the whole cascade from there. Alright, let us focus on each of these three adrenal cortex hormones and see what they do, beginning with mineral corticoids. To understand mineral corticoids, we need to know about the kidneys and their functional units called the nephrons. So the nephrons are the functional units of the kidneys. There are millions of these. And these guys are responsible for filtering, reabsorbing, and secreting things from our body, and thus also has a major role in controlling our blood pressure. So kidneys, the nephrons, have a big role in controlling blood pressure. When there is a decrease in blood pressure, the kidneys will reabsorb water and sodium back into the blood, and either reabsorb or secrete potassium in exchange. The increase in water and sodium in the blood will then increase blood pressure back to normal. Aldosterone secreted by the zona glomerulosa of the adrenal cortex will actually stimulate this process, thereby increasing blood pressure. Aldosterone primarily works at the distal part of the nephron, known as the distal convoluted tubule and the collecting duct. So aldosterone stimulates water and sodium retention, thereby increasing blood pressure. It also actually tells potassium to be secreted out, thus can lead to hypokalemia. Anyway, let's talk about glucocorticoids. Glucocorticoids, primarily cortisol, is secreted by the zona fasciculata and has many functions. We mentioned it has a responsibility for negative feedback to the brain, telling the brain to reduce the secretion of ACTH. Glucocorticoids have other functions, such as causing hyperglycemia. It does this by stimulating the liver, or telling the liver to make more glycogen stores, which will eventually fill up. It tells the liver to make more glucose, gluconeogenesis, tells the liver to increase protein breakdown, and actually induces insulin resistance, as well as increasing fat deposition. All this will either result in too much glucose in the liver, which will eventually be shunted into circulation, or because of the insulin resistance, this will cause the inability of glucose to be taken up by cells, thus leading to hyperglycemia. Glucocorticoids also increase blood pressure and suppresses the immune system. It suppresses the immune system, which helps decrease pain sensation, but at the same time it will increase the risk of infection. And this is because their immune cells are being suppressed and thus are unable to defend our body. Finally, glucocorticoids also stimulate osteoclastic activity in the bone, leading to osteopenia and increasing the risk of osteoporosis, thus increasing the risk of bone fractures. The final hormone secreted by the adrenal cortex comes from the zona reticula, which is the area of the adrenal cortex which release androgens. It's important to know that unlike aldosterone and glucocorticoids, androgens have minimal role in stress. Androgens actually promote prostate growth in men and help with the development of masculine characteristics such as a deep voice and hair growth. In females, androgens, adrenal androgens, are important in libido, and thus a decrease in androgen production will result in a decrease in libido, decrease in sexual drive in females. Those were the general effects and functions of the three hormones produced by the adrenal cortex in response to long-term stress, amongst many other things. It is important to learn about another factor which actually affects the release of aldosterone, not really related to stress. This other factor is a molecule called angiotensin II, which is part of the renin-angiotensin-aldosterone system. To understand this topic, we need to go back to the nephron, the functional units of the kidneys. As mentioned, the nephron filters things from our blood. The afferent arteriole are the vessels that enter the head of the nephron for filtration, and the efferent will leave the head of the nephron. The things filtered will go through the nephron tubes and essentially come out as urine. Now, when there is low blood pressure, it will decrease the filtration rate, and it will also decrease the pressure in the afferent arteriole coming into the head of the nephron. This decrease in pressure essentially will stimulate the release of renin from the juxtaglomerular cells. And renin will essentially start the renin-angiotensin-aldosterone system cascade, which Eventually, the final outcome will be activation of the final product called angiotensin 2. Angiotensin 2 will stimulate zona glomerulosa to secrete aldosterone in the attempt to increase blood pressure by targeting the nephron. To remember, the aldosterone will target the nephron to retain and reabsorb sodium and thus water into the vasculature, leading to an increase in blood pressure. I hope you enjoyed this video. Thank you very much for watching. Bye.